How do you graph polar equations by evaluation? Well, evaluation is just the same as how we graph by plotting points in every other type of equation we tried to graph. You create a table with the angle as input values, evaluate the polar equations to find the output values, meaning r, the magnitude, and then graph the output coordinates, r comma theta. So if we have something like r equals 4 sine theta, what we're going to do is we're going to create a table with theta and r, plug in some values, 0, 30, 45, 60, 90, 120, 135, 150, 180, and then continue with 210, 225, 240. In order to get a thorough graph, it's important to include as many points as possible, because some of these do not appear the way you expect them to. So what we're going to be doing is we're going to be plugging in 0 in for theta, and then multiplying by 4. So plug in 0 for theta, we get out 0 times 4 is 0. Plug in 30, we get 1/2 times 4 is 2. 45 in gets root 2 over 2 times 4 is 2 root 2. 60 in for theta gives root 3 over 2 times 4 is 2 root 3. 90 in gives sine of 90 is 1 times 4 is 4. 120 in for theta gives root 3 over 2 times 4 is 2 root 3. 135, sine of 135 is root 2 over 2 times 4 is 2 root 2. 150, going in for sine, gives 1/2 times 4 is 2. And 180 going in for sine gives us 0 times 4 is 0. Now for quadrants 3 and 4, sine of 210 is negative 1/2 times 4 is negative 2. Sine of 225 is negative root 2 over 2, so negative 2 root 2. Sine of 240 is negative root 3 over 2, so negative 2 root 3. Sine of 270 is, negative 1, so times 4 is negative 4. Sine of 300 is negative root 3 over 2, so negative 2 root 3. Sine of 315 is negative root 2 over 2, so negative 2 root 2. Sine of 330 is negative 1/2, so times 4, negative 2. And now what we can do is plot these points. Note that this is r and this is theta, and usually we write the points in the opposite order. Because theta was our input and r was our output, we wrote it like this. So 0, 0. 2, 30. 2 root 2, 45. That's a little bit less than 3 is 2 root 2. 2 root 3, 60. That's somewhere between 3 and 4. And then 90, 4. Yes. Now 2 root 3, 120. Gives us about there. 2 root 2, 135. 2, 150. And then 180, 0. Plotting these, well, note that the angles are down here, but the r values are also negative. So when we plot negative 2, 210, it's actually going to be back the same as 2, 30. Same thing here with 225, negative 2 root 2, 225. That's the same as over here. So actually all of these points get repeated in this particular graph. This is not always the case. but because these r values are negative that we're getting out, we get these points. So here is the graph, and that should look like a circle to you. So this is, in fact, the equation of a circle with radius 2, centered at 2, 90 degrees. Here, r squared equals cosine 2 theta. What we're going to be doing is we're going to be plugging in a number of values for theta, getting out values for r. So, for example, if we plug in 45 degrees, we would get out cosine of 90, which is 0, and then taking the square root of that, getting 0. So this is the type of thing that we're doing. I made an error in setting that up. This is theta comma r. This is theta comma r. Rather than having you see me walk through plotting all, substituting in all these values, I've typed them out for us. But essentially, all I did was I plugged in 0, I evaluated, and then I took the square root of both sides to find out what r would be. So 0, 1, sorry, 1, 0. We have square root of 2 over 2. We have 0, and then it gets undefined between 60 and 120. That's interesting, but there shouldn't be any points between 60 and 120, or more appropriately between 45 and 135. And then at 135 at 0 again, then root 2 over 2, then 1 at 180, and then root 2 over 2. So these are, now we're over here, and then 0. And then undefined between 240 and 300. At 315, it's root 2 over 2. Sorry, at 315, it's 0. At 330, it's root 2 over 2. So we get this interesting shape. Kind of like an infinity sign. If we have this graph, we're going to want to, again, plug in values for theta, figure out what r is going to be, and then use those to graph the points. I think I made the same mistake calling these r comma theta. These are theta comma r, theta comma r. So let's plot these points. Undefined at 0. Okay. Then we want to go 30 degrees with 4 plus 2 square roots of 3. 2 square roots of 3 is somewhere around 3.4, so this is about 7.4. 7.4 at 30. 2 plus square root of 2. Square root of 2 is about 1.4, so this is about 3.4. 45. 2 comma 60. 1 comma 90. 2/3 comma 120. Negative 2 minus square root of 2 at 135. So square root of 2 is about 1.4. So this is about 2 minus 1.4 is 0.6. 4 minus 2 square root of 3. Again, this is about 0.6. Then we get it 1/2. Again, same values as on the upper side. We get 2/3 and then 1. 2 comma 300. 2 plus square root of 2. And then 4 plus 2 square root of 3. So if we were to connect these, to me this looks like a parabola. So in fact, this is the equation of a parabola with the focus at the origin. So this is how we graph polar equations by evaluation. It is tedious, but it is able to be done if you plug in enough values and then connect the dots.